Let's now have a look at the operators you've got to know about for OCR A-level, starting with the ones which are relating to maths, the arithmetic operators. Now, if we were to say formally what these do, well, they take either integer or real operands. They will produce either integer or real results. As a reminder, the operands are the data in an instruction. In this case, the operator goes in the middle of the two. And like I say, the operands are numbers here and it produces a number result. The first three are just standard mathematical symbols. Multiplication is the asterisk. Exponentiation is a fancy way of saying raising to the power, and in OCR pseudocode they use this little caret symbol. Now there is a misconception this is doing, it's always doing squaring or it's always doing cubing. It depends what the second number is. So 2 caret 6 is saying 2 to the power 6, which is 64. 5 caret 3 is saying 5 cubed, which is 125. So it's first number is your base, second number is your exponent. Now we've got two types of division in programming. We've got normal division, which is often also called real division. This is a normal /. This will always give you a real outcome, a real result. Real being another word for a float. So 40 divided by 4 is 10, but it's written as 10.0 because it always gives you a real data type. And we can do normal division, so to speak. We have a fractional part, that's perfectly fine with real division. Quotient has also got a few different names. It's also called integer division in contrast with real division because this always gives you an integer result. It's written as div in OCR pseudocode. People often see that and just think divide. And it is divide, but it's not normal division. We are always getting an integer, which means for whole number outcomes, like it's not really a big change, but 28 div 5 isn't 5.6 with div. It is just 5 because it's getting rid of any fractional part. It's not always rounding down because if it was a negative number, it wouldn't quite do the same thing, but it's just getting rid of the fractional part. And lastly, modulus, also called modulo and mod for short, is giving us the remainder from a division. So it's doing a division, but only giving us what's left over after it does the div part, essentially. So 40 mod 4 is 0 because 4 went into 40 10 whole times and nothing was left over afterwards. Whereas 28 mod 5 is 3 because the nearest 5 could get was to 25. It gave 3 left over. So for mod, think about how many whole times the second number goes into the first number. And if there's anything left over after that, that is what mod gives you. Comparison operators are really versatile. They take all data types as operands, but they always do produce a Boolean result. And we use these as part of conditions in if statements and while loops and things like that. So you obviously will recognize these. Most of these are fairly self-explanatory. We use 2 equal signs for comparison. 1 equal sign is used for assignment. So we have to always use this when we're comparing. Capital letters do matter, so lowercase h is not the same as uppercase h. Not equal to is the opposite of equal to, clearly, the exclamation mark and the equal sign. With the less than and greater than signs, the biggest mistake is just people mixing up the two and which direction it goes in. Now, it's a really childish way to think about it, but if you picture, the crocodile, the bigger open side is the greater than side, and the smaller end, the closed end, is the less than sign. So here, 5.2 is not less than 5.2 because they are equal. Whereas if we had less than or equal to, that would be true. Greater than, exactly the same. -5 bigger than -3 is false because it's smaller, and it'd be the same result regardless whether it's equal to or not. And the last set we'll look at now are the Boolean operators, which come up in different areas of the course as well. These always take Boolean operands and they produce Boolean results. And again, we use these to make more complex expressions for use in conditions. So these are not and and or as our basic ones. We also have XOR, which comes up later in the course, but isn't used in any of the programming examples. So you've not got to know about XOR within programming. Not will just flip the operand, not used that often in programming, I would say, ironically. This just flips whatever the condition was. We use and or though a lot more often. And is very strict. Both sides of and have to be true for the whole thing to be true. So here, 5 is less than 10. That is true. 15 is not less than 15. And so because this right-hand side is false, the whole thing is false. Or is a lot kinder. It returns true if either or both of the operands is true. It's only ever going to give you false if they're both false. So for same numbers here, 5 is less than 10, that's true. Therefore, the whole thing is going to be true regardless of the fact that actually 15 is not less than 15.